Welcome to Supermetrics and the Many Bears, a modern-day fable about searching for the perfect database. So this presentation from us is kind of a bit weird to do, right, Victor?
Yeah, COVID and all that.
Yeah, I mean, normally we'd be in front of you in an audience, you'd be looking at us, you'd be waving at us, you'd be giving us questions and things like that. We can't do that. We kind of broke into our actual office and are presenting this to you together so that we can have a conversation with you about looking for the perfect database in our organization and some of the stories and the problems we had. And we'd love for you to ask questions of us afterwards so that you get the most out of this. But certainly we decided that the story format was better than trying to have lots of screens. So the deck itself is fairly short, but the conversation we're going to have is going to be much longer. And obviously it is a bit strange talking at our computer screens rather than to you all. So if we stumble, we'll probably pick each other up and go on from there. So first of all, I'd like to introduce myself. My name is Dups. I have a very long name. I'm a software and data geek, and I started out started out a very long time ago, but I worked for a company called Wijayawardhana, and then from there to MySQL and Sun. And then I started my own startup, Empire Avenue. And then somewhere along the journey, I discovered this incredible startup that our CEO, Mikhail, had started and joined the company about 3 years ago here in Finland. So we are presenting this to you, the depth of the night in Helsinki, Finland.
My name is Viktor. I also have a background as an entrepreneur and a software developer. And I've been at Supermetrics for about 4 years now. And the hair has grown about the same pace as the company, as you can see from the old photo.
And actually, when I started, we were about 9 or 10 people. You had just started 3 months before that. And now we're in 3 countries and 120 people and an amazing growth story and one of Finland's incredible growth startups, if not one of the fastest growing companies in the Nordics. So with that being said, Victor, why don't you give us some information about Supermetrics?
Yeah, so a quick intro to what we do. Basically, we bring data from one place to another, and that sounds very, very simple, right?
Extremely simple.
But the reality is not that simple. It's a lot more complex than that. We integrate with over 60 different platforms. We call them data sources. So mostly in marketing, but also from basically any area. We fetch data from these data sources, process them in our backend, store some data in different types of databases, and push the data out aggregated to different types of tools where our customers do reporting. So typical use case is the spreadsheet tools, Google Sheets and Microsoft Excel, very popular. Data visualization tools, but also data warehouses, especially for the bigger enterprise customers.
Now, you said store data, but in most cases, do we actually store data or?
Yeah, well, a lot of the processing does happen in real time. So we do store some data, but that's mostly for caching. So it's the typical situations we fetch most of the data actually from the data source in real time, and that brings some interesting challenges.
So you can see some of the numbers there. There's like terabytes of data being transferred, hundreds of millions of queries, or 75 plus million queries, and something called 3 billion query seconds. What is a query second, Victor?
By query second, we mean a query being processed on a server for 1 second.
Right. So what does that query processing look like?
So here's a simplified overview of what our application looks like. It's a pretty standard setup, actually. We have requests coming in. We put them in a queue. We have workers picking up jobs from the queue. We go to the data sources to fetch the data, and we store that, as I said, in different types of databases, depending on the use cases. And we'll dive more into those different types of databases in a while.
Right, and of course, when we talk about storing, we're always talking about caching in many cases. But of course, we have some data sources where we have to store the data for a longer term cache or a longer term amount of time.
Yeah. So, for example, in some cases, the data source APIs don't provide the type of reporting APIs that we need to gather the data in real time. So in that case, we basically need to fetch raw data from the data sources, store it somewhere, and do the aggregation on our end.
Right. And so the interesting thing about talking about this application is that, I mean, this is a pretty standard stack, as you saw, like a pretty standard tech stack of workers working on things, processing data. I mean, obviously, we can't get into the secret sauce of how all that happens, but in terms of applications, it's not that unusual. And that's actually one of the interesting things about this application is that we have many different types of use cases that we have to deal with. But I think if you want to look at our application as a kind of a mental picture, you could look at it from the perspective of Finland itself. So this is a beautiful country, and I hope after coronavirus is done with and COVID-19 is gone, you get a chance to come here to Finland and visit and come to our office and say hi to us, certainly. But we have in Finland we have something like 30 million lakes. I heard something like that, like a few lakes.
Maybe,
per
but that sounds a bit much. But
okay, so
definitely more than 1,000.
Oh, definitely more than 1,000. Okay, so I think it's like in the 30,000s, 100,000. I don't know, but it's a lot of lakes in this country. It's beautiful, and of course, water flows from lake to lake, from river to river. And if you think about data as that water that is flowing across all these lakes and rivers through an application, then wherever data starts to collect, then it becomes a pool of water. Something that you have to dive into, you have to dissect, you have to figure out what's in there. And these pools of data become larger and larger in an application, and then they become a lake. And we all know that trying to cross a calm lake is better than crossing a stormy one. Yeah. Viktor has to deal with a lot of stormy lakes when it comes to databases. So our landscape is filled with these kind of pools. And one of the interesting things, and we don't get into this in this presentation, is that when you look at any technology stack, we tend to look at data structures or databases, and these are from vendors like MariaDB or Google BigQuery or wherever. But wherever you have a bunch of data, that is in itself a database and can become a problem for us. And that could be a queue system. So just keep that in mind as we go through this, because it kind of feeds into all the different types of databases that we have. Now, we structured this presentation as a fable, and the fable that we chose was Goldilocks and the Three Bears, because the three bears were testing out all the different beds to figure out which one was the perfect bed.
Wasn't it Goldilocks who tested the beds?
I believe so. Actually, you're right.
But anyway.
But that's because the bears were sleeping in different types of beds. Exactly. All right. So, fables aside, so where does Momma Bear sleep?
Momma Bear is the traditional relational database. So in our use case, this means a lot of MariaDB, it means some Aurora MySQL, and it means Google Cloud SQL. We're a hybrid cloud, so we use multiple cloud vendors and different solutions there.
So what's Momma Bear looking for, Viktor?
Well, it's a typical startup scenario, right? You start with a small application, you build a proof of concept. Especially back in the days, the obvious choice for data storage was the relational database. And that's where it all began for Supermetrics as well. But we still use a lot of relational databases, and MariaDB in particular. And the strength there is obviously the ability to do table joins. There's the indexing, which we use very, very much to have performant queries. But apart from that, we don't actually use the more advanced features of relational databases that much, like procedures or triggers or similar.
And that's an interesting thing about us, actually. We use relational databases, but we don't necessarily use all the features inside of a relational database. But transactional ACID compliant data is very important to us.
That's obviously very important, yes, for the core application data.
But relational databases have had a problem with us as well.
Yes. As I mentioned, started out small, yes, that's fine, a couple of hundreds rows, maybe a few thousands of rows. But then the business grows, suddenly there's millions of rows, we add new features, joining tables, can be dozens of millions of rows. We do a lot of inserts, we do a lot of updates, a lot of deletes.
Lots of replicas.
And especially traditionally the use cases or the type of things that we did wasn't necessarily optimized for relational databases. So other types of database solutions might have been better options there.
And of course, other problems with relational databases for Supermetrics has also been we may have databases in different parts of the world. They're not necessarily distributed, and it's hard to deal with multi-master systems and things like that. So management of those kind of systems can be a problem. And then if we go into some of the vendor locked-in solutions, such as AWS Aurora or Cloud Spanner, then, well, we're vendor lock-in.
Hard to be hybrid cloud then.
Yes, hard to be hybrid cloud, and you end up optimizing for each of the cloud vendors that you have, which isn't necessarily where we want to be as a company. So
that's Mama Bear in a nutshell. What's Daddy Bear then?
Oh, Daddy Bear. Daddy Bear's a simple kind of guy. He doesn't like this SQL stuff, and he thinks that we should just be able to get the data out of the thing. So Daddy Bear for us is Redis Enterprise, which is the enterprise commercial version of Redis that you get on open source. And I'll explain a little bit more about that later. We have Elasticsearch, and believe it or not, we have, I'm going to consider Daddy Bear to also be our file systems as well. So
you're kidding, right?
Come on. Hey, you know the system as well as I do. So yes, EFS and Google Cloud Storage. Yeah, like I said, Daddy Bear's a bit simple. So yeah. So what's Daddy Bear looking for? Well, like I said, he's simple. He's not looking for relational data. It's no SQL data, non-relational. Very much key value systems or document-based systems. We're looking at documents or data sets that are 10 bytes to hundreds of megabytes or more in our case. Now, each of the three main areas there, or four things there, kind of have a different use case for us. So, for example, Redis is very much our short-term caching solution. In memory as much as possible. Then we have Elasticsearch is actually our metadata layer that we query for our logs and some analysis. And then we have our file systems. And the file systems is, well, there was a reason why we ended up in the file system. And that was because we were trying to store huge amounts of data into Redis. And I don't mean transactions into Redis. I mean like hundreds of megabytes of data into Redis, which...
Hundreds of gigabytes.
Hundreds of gigabytes. Wow, what's a meg? What's a gig? It all comes down to the same thing, right? So end up, we couldn't do that. But we needed to get this data back out. And so we decided to put it into file systems. It actually worked out really well, which is amazing. But of course, the speed is variable. Networking, file I/O, different cloud vendors.
Yep.
Yeah.
But it has its purpose for very big files.
Indeed. And we discovered the efficacy of that. Now, one of the I mentioned Redis Enterprise is because we moved from Redis open source to Redis Enterprise because there's a lot of things that gives us. And there's a story about all of this that comes back to MariaDB at the end of this. So Redis Enterprise gives us the ability to use SSD storage instead of memory so for large files. And this can be very useful in sub-second queries that we need to do. So, but we wanted to share some of our war stories, and one of the war stories actually was fairly recent, and I'm going to mention a few names in our company, Nicholas and Method. They had to mostly deal with this. In their situation, they were dealing with a data source where we did need to store the data. This wasn't a real-time data. We needed to fetch the data for customers. And when we initially did our tests and did the scoping and the specs, we found that it was small bits of data. We could throw it into Redis. I think that was
the natural solution for
absolutely
key value store.
Key value store. It makes perfect sense. In memory, we're going to do that. And suddenly we were doing a test run with actually, I don't think it was just a handful of customers. And suddenly that data set wasn't the 5-10 megs that we were talking about, actually turned into the 50, 100, 150 megs, which...
Gigs again,
megs, gigs, you know what I'm talking about. And that can be a bit of a problem when it comes to memory and cost. And it strikes at the heart of a CTO's heart here. So what do we do? What did we do? Well, we had to think about it again, and we had to go from a non-relational database to a relational database. We actually had to rethink how the application was working. And this comes down to one of the problems with non-relational NoSQL data structures, is that your application has to deal with that. And in our kind of analytical aggregated, where we're looking at data aggregations, sometimes that is actually not the best way to deal with it. And there is a good reason why SQL was created, and you kind of walk right back. So what do we end up with? We ended up with, in this situation, moving from non-relational to relational.
Back to MariaDB.
Back to MariaDB. Actually, we actually walked right back to MariaDB, which was entertaining in that we discovered a lot of ways of improving even that solution as well. So, with that being said, however, next up is
Baby Bear, last but not least. And here we're talking about the data warehouse type of storage. So in our case, a lot of Google BigQuery, but also Snowflake and PrestoDB. And if you're not familiar with Snowflake and PrestoDB, Snowflake is a vendor that provides a data warehouse solution that works across clouds. So at least in Google Cloud, AWS and Azure, whereas PrestoDB is an open source file-based
columnar stored database.
Yeah. Originally developed by Facebook.
Right.
But yeah, it's Baby Bear, but not a very tiny Baby Bear. So we're talking very, very big data here. But the key is that, for us at least, is that we're able to do able to use SQL. So we can do table joins, and we can still query a lot of data really fast as long as we do proper database structuring.
But it's not really suited for anything small, right?
Right. There's always a cost to everything, and in this case, both storage and querying can be quite expensive depending on the use case. So it's not the ultimate solution to every use case.
And of course, for us, BigQuery and Snowflake, these are potentially internal databases that we use for internal analytics and things like that. But for one of our scale cases, we ended up going with PrestoDB. And what was the use case there?
Yeah, so there the interesting case was blackout.
And this is what happens when we do this very late at night, kids. No, in this case, we were taking data initially into MariaDB.
Right, so we're working with MariaDB and hit the limits there. The queries were just too massive for MariaDB to handle. And at that point, I think it was Andy, our head of data engineering, who came up with the suggestion that, hey, let's try PrestoDB. It could be a better fit for this particular purpose.
And it was, from a cost perspective, from an ease of use perspective. I mean, we now query gigs. I think we actually query a terabyte of data in there somewhere, and has been quite effective for us. But of course it has its downsides. It is file-based. It does have limitations in changing table structures and things like that. It's
updating data is not really an option.
Exactly.
It's only inserting and deleting.
So there's lots of issues with each of these particular things. But
an interesting point here as well is that we actually use Redis as well.
Oh, right, of course. We couldn't actually just do it just against Presto.
Yeah, so to insert row by row or even like hundreds or a few thousands of row at a time wasn't really an option. We needed to first gather bigger data sets and then push them all, push all the rows at once. So we actually used Redis there for the gathering of data.
And that brings us to whether Goldilocks. See, I did get the fable right? Okay. See, eventually, right. So did Goldilocks find the perfect bed? So let me ask a question before we get into this slide and talk about this, Viktor. How do we actually get our data into Elasticsearch, by the way, for our logs?
Yeah, so we push our logs from application level, but we definitely do not push them directly to Elasticsearch.
Oh, whoa. Why not? I mean, come on. It should be able to handle this.
Yeah, but then if Elasticsearch goes down for some reason...
Has that ever happened? Really?
Nah.
No?
Really.
No.
Then suddenly we're out of logs, and the logs are very important for us, so we can't let that happen. So again, we use Redis as an kind of intermediary storage there.
Well, I think this is the moral of the story, though, in the end, right? So in everything that we talked about, I think this is where we also... So here, so with some stories that we've talked about going from relational to non-relational. But in a lot of cases where we have actually gone from non-relational back to relational, as I've said in the stories, and part of that is we keep coming back to SQL. We keep coming back to the ease that we have with working with SQL, and it's like putting in an old coat, and you just feel comfortable in it, and it's easy to get going. So MariaDB and MySQL has been a constant feature in our lives. I don't think it's ever gone away, and in fact, we're expanding our use. Yeah. But more often than not, we end up with
one form of hybrid solution That's usually where we get the most performance and the most cost effectiveness and so on.
So, and that's an interesting thing. It's like, so we kind of look at our data structure or the database for a specific part of our application, not as one database, but as a hybrid database. One cannot exist without the other. It's not saying that, we can just live with one. And sometimes it's three.
Yeah, it can even be all three of them. So, for example, having the final ultimate set of data in the data warehouse, storing part of it in a traditional relational database like MariaDB, and then maybe some aggregated data or very often used data in Redis for the more key value type caching.
And maybe that's the perfect solution. Do you think that there is possibly somewhere out there a perfect solution that we still haven't tried, or that we can use for our scale, like something that is globally distributed, data warehouse, columnar, maybe, or something like that, with a relational database as well, and some document or non-relational stuff, but also non-vendor lock-in across all our hybrid clouds solution. And what am I missing here? Oh, something in memory so that you can use it for key value as well. Like,
it sounds like a dream.
It is a dream. One that, I know there's a lot of people who've tried this, but yes.
To be honest, I don't know the answer to your question, but I certainly do hope that there is or will be. We've been following the developments of SkySQL with a lot of excitement, partly because of the multi-cloud and inter-cloud capabilities that you mentioned. We do use 2, if not 3 clouds, and we need to be able to have the data travel between these clouds. And if we do it ourselves, it means a lot of self-managed databases and a lot of maintenance associated with that.
And we don't have a lot of DBAs, though there might be someone watching that might want to come work for us, right? I mean, there's all sorts of cool things to do here, but I interrupted you, sorry.
Yeah, but no, we don't have like dedicated DBAs, at least not at this point in time. So one option is to utilize the very best knowledge and experience that there is out there in the form of SkyDBAs, and that's essentially a model that we have tried already with Redis Labs, as you mentioned, in the case of Redis. So using the enterprise solution for that.
And I think Supermetrics is an interesting use case. I think it's something, and I'll be honest, when I started here, my first thought was, this is going to be simple. We're going to use MySQL, as we already have, MariaDB, of course, plus Redis. Everything's going to be simple. But in actual fact, as we have scaled and as we have grown, we have so many different use cases that like nothing works just as you would like in one single database. And that seems to be the crux of the matter. They always say use the best tool for the job.
Exactly.
And that is true. We can't seem to use the best tool for the job. We have to use the best 3 tools for the same job to do the same query. It is not a joke to say that our application sometimes in one code piece might query the Redis, the relational MariaDB, and the data warehouse type structure within a 20-line span, and combine those 3 things together to give back the data set that we need. And that's a unique point, I think, in some cases.
Yeah.
So.
Yeah, and that's something where, as I said, we're excited about the potential of SkySQL and also the hybrid aspect that SkySQL provides.
But the other moral of the story is, of course, is how important relational databases have become, even though we thought that NoSQL, SQL battles would be waging even now, and our lives would be more NoSQL than SQL. So
we still find ourselves doing a lot of table joins.
Yes, we do. Yes, we do. But hey, one of the interesting things, and I think time is getting pretty short here for us. So we do want to say that Viktor and I are basically like the messengers of an amazing team at Supermetrics. And I would be remiss to say that even these 5 names on this list, on this slide, is just the tip of the iceberg. Our thanks to Andy, Dimitri, Nicholas, Metod, Mikhail, and lots of other people. So, and by the way, I just want to put a plug in for Supermetrics and say that we are hiring, so please do check our jobs, but there may even be jobs that we haven't posted, so please do get in touch with us. Thank you very much to MariaDB Server Fest, to Anna, to Kai, to all the wonderful people there. Thank you for having us. It is very strange giving this presentation from this format. Viktor and I, you and I have had a lot of fun trying to set this up today.
Very fun.
So we hope you'll come visit us here in Finland, and looking forward to the questions, and we will answer as best as we can. It was a pleasure, and see you next time.